We're going to watch a video here and then do a little bit of an investigation of a situation.
Joy Milne first noted something odd about her husband's scent when he was 45. Shortly afterwards, he was diagnosed with Parkinson's. Now universities are testing if it's a coincidence or a newfound precaution. Here's Mike McCarthy from our British partner, Sky News.
When she was a teenager, Joy Milne started to realise that she had an acute sense of smell. But it was only when she noticed a change in her husband Les's odour that the incredible potential of her super sense became clear.
He was an anaesthetist, he was in a close situation in theatres and he was working long hours, and I presumed, and the Parkinson's tiredness had kicked in then, but we didn't know that. And because he was so tired, I just thought, well, you're not showering enough, and I said so.
At first, Joy didn't know what the smell was until she recognised it in other people and said so at a meeting to discuss Parkinson's.
And I thought, this is it, this is the right moment. And I stood up and said, why are we not using the smell of Parkinson's? I can smell it in this room all around me.
Now at Manchester University, researchers supported by the charity Parkinson's UK are harnessing Joy's special skill. Once Joy's incredible ability had been recognised, she was given by the university a number of T-shirts. Now, half of them had been worn by Parkinson's sufferers, the other half by a control group. She got them all right, apart from one.
So what we're going to do now is we're going to kind of look at some of these questions that come out of this situation. Why would it be important for someone to be able to smell Parkinson's? Well, if you kind of think about why it would be important, it'd be important to know if we could identify quickly if someone had Parkinson's just by a smell. It could be expensive to run a test. We might be able to identify it sooner and maybe provide the person more support and services to help them understanding what the disease is. So it is kind of important if we could identify a disease early. The next question asks, like, how many correct decisions would you expect Joy to get out of 12 if she really couldn't smell Parkinson's? She was just guessing. Well, if you think about the situation we're in, you either have Parkinson's or you don't, in this T-shirt example. So it's like a 50-50. Half of them did, half of them didn't. So it's like a coin flip. You're basically guessing heads or tails. Well, if you really think about it, with a probability of about 50% out of 12, that 12 times 0.5 gives you 6. So I'd expect maybe 6 T-shirts guessing 6 T-shirts correctly. Do we have some evidence that Joy can smell Parkinson's? Well, we're expecting 50%, 0.5. Joy got 0.92. We might have some evidence. Where's that tipping point for us? Well, you kind of think about it. 6 out of 12 is what we expect. 7, probably not a big shock. 8, it's about 2/3. Not necessarily stunning, but it could be. 9, now we're probably getting in the ballpark. 10 and 11, yeah, definitely 10 and 11. So what we're going to do is we're going to do a little bit of a simulation here. What we're going to do is we're going to pretend that we're Joy and we're going to smell some T-shirts. So what we have here is we got a bunch of T-shirts. And what I'm going to do is I'm going to go ahead and guess. I'm going to go, yeah, I'm going to say yes. No. Yes, I'm going to say that's a yes. I'm going to say that's a yes. So I've got 3 yeses. Remember, there's only 6. No. No. So I'm still at 3. 4, yeah. 5, maybe, yeah. No. 6. So these 2 would be no's. Wow. Pretty good. I got it as well. Interesting. Let's try it again. In this case, let's just do 6 yeses. 1, 2, 3, 4, 5, 6 yeses. 1, 2, 3, 4, 5, 6 no's. Got it out of 12 again. Wow, maybe I have the skill. I'll do it one more time. Yes, 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 yes. No, 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 no. Okay, 6 out of 12. So what I'm going to do now is I'm going to pause the data collection, and what I'm going to do is I'm just going to kind of close it out. I want to get a lot of data. So what I'm going to do is I'm going to let the computer run it 197 more times. And what we want to do is we want to watch up here and watch what happens when we do this. So I'm going to pause. I want to add the data to it. Watch what happens. Eventually, slowly, or maybe not. I guess we'll see. Okay, so You know something? I want to make sure we have a number, so I'm going to add 3 more. Okay, so now we got 2,000 times. Here's our dot plot. Here's our dot plot for 2,000 times. We have a symmetric distribution. Now look at this guy right here. This guy kind of looks like you can fold it in half, and when you fold that in half, it kind of matches up on both sides. When we look at these data points on here, that would be 0. That would be, you know, actually getting, that would actually be getting nothing right. You guess out of 12 and you're never right. And it looks like we actually got that at least one time. Over here is Joy. Joy got 11 out of 12. So that's saying you guess 11 correct out of 12. Actually, if you look at this, our max is 11. So we actually never got even 12. We're at 11 out of 12. So what I want to do is I want to see where we are in Joy. So I'm going to do greater than or equal to 11. And I'm going to ask for a count. We got 6 times. 6 times out of 2,000 we matched Joy. 0.3%. 0.003. 0.3%. You think that's evidence? I'm going to ask, do you think that's evidence that maybe Joy has something going on here? I would. Actually, in statistics, the number we can use as our tipping point is 5%, not 0.5, 5%. So 5%. This has got a decimal point, 0.3. I'm talking 5%, 0.05. We got 0.003, so we got a really low number. So I think we might have evidence to say Joy can smell Parkinson's. So there's just one little piece of information I want to kind of add to it to close this out, and that's the gentleman had one more thing to say, and let's kind of hear what he has to say.
She got them all right, apart from one. That person went on to develop Parkinson's.
So let me repeat what he just said. What he just said was the following. She got 11 out of 12 right. She missed on 1. And the one she missed on was someone who was in the control group, not Parkinson's, that ended up developing Parkinson's. So in other words, Joy ended up being 12 for 12. Again, let's take a look at our chart here. We never got 12 out of 12. I'll change it here to 12 and count. We never got 12 out of 12. So you know something? We actually may have evidence here that Joy actually can smell Parkinson's disease. So this is kind of an investigation just to dig into what statistics are and how we're going to use them in this class. Hopefully that kind of gives you a little bit of an enlightening activity.